You are listening to The Vocal Technologist. Spoken tech for your ears.
Hello and welcome back to The Vocal Technologist. It is officially Product Thursday, which means, we're putting away the marketing slides, ignoring the hype cycles for a minute.
And rolling up our sleeves.
And rolling up our sleeves to look at how great products actually get built.
That's right. And today, specifically, we are looking at the data side of things.
The plumbing.
The plumbing.
I feel like every time I open my phone, there's another headline about AI taking over the world or, writing Shakespeare.
Or predicting what you want for lunch.
Right, before I even know I'm hungry.
Yeah.
But nobody talks about the pipes.
Because pipes aren't sexy. Until they burst, that is.
Exactly. We're so focused on the shiny chatbot interface, the magic, that we completely forget about the massive data engineering that's required to keep it from, just crashing.
Right, or hallucinating.
Yeah.
So looking at the research we pulled together, we're going to get into that intersection. Huge data engineering and the practical application of AI.
And we're not just talking about theory here.
No, not at all.
Yeah.
We're looking at how companies like Netflix, Pinterest, and yes, even OpenAI are actually moving and using data right now.
Okay, this is going to be a fun one. Let's unpack this. I want to start with this idea of AI as a teammate, because usually the whole narrative is AI is coming for your job. But you found this really interesting case study from Whatnot, the live stream shopping platform.
Right. Whatnot is a super fast-paced environment. I mean, if you've ever seen it, it's frantic.
Oh, yeah.
And that kind of live streaming just creates messy, high-volume data. They realized they needed to scale their data science capabilities and fast. Now, the traditional corporate move is what? Hire 20 more data scientists?
Or the panic move,
Yes.
try to automate everything and, fire the humans.
Precisely. But they didn't do either. They took a third path. They built custom tooling around what they call strong prompting patterns.
Strong prompting patterns. Okay, break that down for me.
Yeah.
Is that just like a shared Google Doc with some good prompts copied and pasted in it?
Well, it's a bit more sophisticated than that. They built actual libraries of reusable, version-controlled prompts and integrated them right into their workflow. But the crucial part, and this is the real insight, is how they framed the output.
Okay.
They treat the AI output as a strong first draft.
I love that phrasing. A strong first draft. It's not the final answer.
It changes the psychology entirely. It takes the pressure off the AI to be perfect, which, let's be honest, it isn't.
Not even close.
And it keeps the human in the driver's seat. It creates a human-in-the-loop system. So the AI does the heavy lifting, the boilerplate code, the initial analysis, and the data scientist focuses on, refinement and strategy.
So they aren't replacing the expert. They're giving the expert a kind of...
An exoskeleton.
An exoskeleton, exactly.
It allowed a relatively small team to support this massive business velocity without completely burning out.
Now, speaking of exoskeletons, we have to talk about what OpenAI is doing internally. You'd hope that the company building the AI is actually using it to run their own business, right?
You would hope. And yeah, from what we're seeing, they are. They've built an internal data agent.
And the rumor mill says this is powered by GPT-5. Is that right?
That is the detail that jumped out in the reporting. But, look beyond the model version for a second. The functionality is what really matters here. This isn't just a chat window where a CEO asks, how many users did we get yesterday?
And just gets a text response back.
Right. This is an end-to-end system.
What does end-to-end actually look like here?
It handles table discovery, it writes the analysis code, and then it generates the report. You see, the biggest bottleneck in data analysis usually isn't writing the SQL.
No, any junior analyst can write SQL.
The hard part is knowing where the data lives.
Right. Which weirdly named table from 3 years ago has the clean revenue data versus the one with the dirty data.
That is the daily struggle. This agent has code-aware data context. It has institutional memory. It knows that table A connects to table B using this one specific key. It reduces the friction between a business question like, how are we growing? And the actual query that answers it.
That is huge, but it implies a big shift in how we build platforms. I mean, if we have robots doing the query writing and the operations, that changes the interface. We always talk about UX for users and DX for developers.
And now there's a new acronym in town.
Let me guess.
AX.
AX, Agent Experience.
Agent Experience.
It sounds a bit like buzzword bingo, I know, but it's a real design constraint. If AI agents are going to be hitting your platform has to be headless and API first. But more importantly, your documentation needs to change.
How so? I thought documentation was just for me when I forget how to configure a server at 2 in the morning.
Well, humans are great at reading between the lines. If a manual is a little vague, we figure it out. We search for it. We guess. Agents can't really do that.
They're very literal, very literal. Documentation needs to be machine readable. And error messages, this is the critical one, they need to provide structured hints.
Give me an example of that.
Okay, so if a human hits an error, it might just say, invalid input. You look at it and go, oops, I typed a string instead of an integer. If an agent gets a generic invalid input, it's just stuck.
It'll just try the same thing again.
Over and over. But if the error message is, say, a structured JSON object that says error, type mismatch, expected integer, receive string, the agent can actually parse that, self-correct, and retry successfully.
So we're teaching the system to explain itself to the robot so the robot can fix itself.
Yes. But there's a trap here. And I really want to highlight this because I'm seeing it everywhere in the industry right now. The multi-agent trap.
Oh, I've seen this. Everyone wants to build a swarm, a hive mind of AIs all talking to each other. It sounds cool.
It sounds very cool. It is also usually a disaster. There's a great rule of thumb surfacing in the engineering community. Most problems are better solved with simple, deterministic workflows.
So don't build a complex brain when a checklist will do.
Right. The metric to keep in mind is this. You probably only need a single agent if you have fewer than, say, 10 to 20 tools. Multi-agent systems add latency, they add cost, and so much complexity.
Right.
Therefore, when you need true parallelism, or you have severe context overload, not for a simple script.
Don't hire a committee to screw in a light bulb.
That is the perfect analogy.
Okay, so that's the agent layer.
Yep.
But agents need data, and moving data is hard. So let's look at how the big players handle their pipes. Because when you're Netflix, you are not just screwing in a light bulb.
No, you are lighting up the entertainment world. And Netflix is a fascinating case study. They had a classic scaling problem, fragmentation. Data was moving across more than 30 different source destination pairs. You know, S3 to Kafka, Kafka to Elasticsearch.
And I'm guessing every team was building their own little custom scripts to move that data around.
It was a mess of bespoke tools. The whole, oh, Dave wrote that script 3 years ago, please don't touch it, problem. So they built something called Data Bridge.
Just the name sounds stable. Data Bridge.
It is. It's a unified platform that orchestrates about 300,000 jobs every week.
Yeah.
But the brilliance isn't just the scale, it's the interface. It's a programmable control plane.
So it standardizes how you move data from A to B.
Exactly. Users can use a no-code interface for simple things, or they can use YAML configurations for really complex pipelines. It creates one central spot for governance and metadata. Instead of 1,000 hidden scripts, you have one visible system.
That visibility is everything. Okay, so while Netflix is moving data, ShareChat, the huge social platform in India, is serving it. And the numbers here are just, they're blowing my mind. They overhauled their ML feature store to serve 1 billion features per second.
1 billion.
Yeah.
It's a staggering number.
So for anyone listening who might not be an ML engineer, what does serving a feature actually mean?
Sure. When you open an app like ShareChat or TikTok, the algorithm needs to decide instantly which video to show you next. To do that, it needs features data points like user A likes cats or user A is in Mumbai. It needs to grab thousands of those data points in a millisecond to run the recommendation.
And ShareChat needs to do that 1 billion times a second.
Correct. And their original design failed at just 1 million features per second.
That's a 1000x gap. What went wrong?
It almost always comes down to the data model. They were using a database that just couldn't handle the throughput because of how they structured everything. So they moved to ScyllaDB.
ScyllaDB, I've been hearing this name a lot. That's the high-performance NoSQL database, right?
It is. Think of it like Cassandra, but rewritten from the ground up in C++ Pro 2.
Right.
But the real magic is this shard per core architecture.
Meaning it uses every single ounce of the CPU.
Exactly. In a lot of databases, different threads have to fight for locks on the memory. It slows things down. ScyllaDB assigns a specific slice of data, a shard, to a specific CPU core. There's no locking, so it's very, very low overhead.
But they didn't just swap the database, right? I'm seeing notes here about protocol buffers.
Correct. They also optimized the data transport. They started using protocol buffers for serialization instead of JSON.
Why does that matter?
Well, JSON is text. It's heavy. It has all those brackets and quotes. Protocol buffers are binary. They're much smaller and way faster to transmit across the wire. And then the cherry on top, they implemented Envoy proxy.
This is the sidecar thing.
Yes. By putting Envoy proxy in front of the database, they improved their connection pooling and, crucially, their caching. They boosted their cache hit rate to 98%.
Wait, 98%? So 98% of the time that request for does user A like cats doesn't even touch the main database.
It served instantly from memory. That is how you get to 1 billion features per second. It's not just about adding more hardware. It's about making the architecture smarter.
That is just incredible engineering. Okay, shifting gears slightly from raw speed to safety. Yelp. We all know Yelp. Massive ad business. And if they mess up their ad budget allocation, real people lose real money.
It's a terrifying production environment. You do not want to test in prod when advertisers' wallets are on the line.
So how do they innovate? How do they try new things?
They built a specific backtesting engine. Now, this is different from A/B testing.
Okay, how so?
In A/B testing, you show, say, 50% of live users the new system. If the new system breaks, those 50% suffer. In backtesting, you take historical data logs of what actually happened last month and you replay it through the new logic in a simulation.
So it's a what-if machine. If we had run this new code last month, what would have happened?
Exactly. They use CatBoost ML models and Scikit-optimize to predict the outcomes. They can validate huge system-wide impacts like, would this change have exhausted the entire budget too early without risking a single dime of live money?
It's like a time machine for debugging.
It allows them to be really aggressive with updates because the risk is completely contained in the simulation.
I love that. Okay, let's zoom out a bit. It talked about tools agents, ScyllaDB, backtesting, but what about the strategy? There was this great discussion recently with Mike Driscoll about the state of dashboards.
The eternal question. Are dashboards dead?
Right. With all these AI agents answering questions like we talked about, do we still need a pie chart?
The verdict seems to be that dashboards aren't dead, but they are being demoted. They're moving to core monitoring.
Yeah.
You still need a dashboard to see if the server's on fire or if revenue just dropped to zero. You need that red light, green light visibility.
But for the ad hoc stuff, like why did sales drop in Ohio last Tuesday?
That's where the agents come in, the reviving the semantic layer. They can bridge that gap from insight to action. A dashboard tells you something happened. An agent can tell you why, and maybe even suggest a fix.
But, and there's always a but, just deploying a chatbot isn't the same as having enterprise AI.
This is such a crucial distinction. A lot of companies think, we bought a license for an LLM, we have enterprise AI now. No, you have a tool. You don't have a capability.
It's like buying a hammer and saying you own a construction company.
Exactly. It's an architecture problem. Without proper frameworks like TOGA and without clear data ownership, you aren't building intelligence. You're building technical debt disguised as AI.
Ooh.
If your data foundation is rotten, the AI is just going to accelerate the rot.
That is a very sobering thought, accelerating the rot.
Yeah.
And speaking of foundations, we have to talk about PostgreSQL. It feels like Postgres is just taking over the world lately.
It really is. We're seeing this concept of Postgres having the gravity of open standards.
I like that image. Gravity.
It's the ultimate anti-lock-in strategy. Because Postgres is vendor neutral and it strictly adheres to SQL standards, it prevents that proprietary capture. If you build on Postgres, you can move your data. You aren't trapped in some specific cloud vendor's walled garden.
It's the vanilla ice cream of databases. It might not sound exotic, but it goes with everything. Everyone likes it, and it never really goes out of style.
Plus, with extensions like PG Vector for AI, it's becoming the Swiss Army knife, too.
Okay, we are coming down the home stretch here. I want to do some quick hits. These are specific tools and tactics from the reading you pulled out. First up, vector search.
This is a very practical tip for anyone building RAG systems. If you're embedding data, specifically JSON data, you need to flatten your JSON.
Flatten the JSON. Why?
Because embedding raw JSON introduces a ton of noise. I mean, think about how a vector model reads text. It sees all the curly braces, the quote marks, the colons.
Just syntax clutter.
Exactly. Those are structural tokens. They dilute the semantic meaning of the actual data. If you feed that raw mess into the model wastes attention on the brackets, not the content.
So what's the fix? How do you do it?
You just flatten that structure into natural language strings. So instead of age 25, you convert it to the user's age is 25. If you do that before you create the embedding, the data shows you can improve your retrieval precision and recall by up to 20%.
20%. That is massive for just cleaning up a text string.
It's the cheapest performance boost you can possibly get.
Next hit, Pinterest. They did some cool stuff with ad modeling.
They used transformer-based behavioral sequence modeling.
Yeah.
Basically, they looked at off-site interaction data.
Meaning what people do when they are not on Pinterest.
Right. What are they looking at on other sites? By modeling that sequence of behavior, they achieved a 45% lift in user checkout performance.
Wow.
Nearly doubling the effectiveness just by understanding the user's journey better.
Incredible. And finally, a couple of new tools for the toolbox. I saw BunQ.
Yes, a job queue built on Bun and Squalite. The pitch is super simple. No Redis required.
I love anything that removes a dependency. Managing Redis can be a pain if you just need a simple queue. And what about SqualDef?
This one's for the database, folks. It's a schema management tool that's idempotent.
Ooh, 50-cent word. Idempotent.
It just means you can run it multiple times without changing the result. You define your schema in plain SQL, and the tool just handles the diffs. No more managing 100 numbered migration files. It makes the database look like the code.
That just sounds like a quality of life improvement we all need.
Definitely.
You know, as we wrap up, I want to leave our listeners with one last concept that really stood out to me. We talked about data, we talked about agents, but there's a missing piece, the context graph.
This is the frontier. We're very good at recording what happened. We have logs for days. Server returned 200K. User clicked a button.
But we're terrible at recording why a decision was made.
Exactly, the decision trace. A context graph tries to capture that reasoning. If an AI agent or a human makes a choice to allocate budget or restart a server, what data did they look at? What was the logic? This is the new institutional memory.
Because if you just have the result, you can't learn.
But if you have the context, you can evolve.
That is such a powerful idea. It's not just about big data anymore. It's about big context.
Precisely.
Well, that is all the time we have. I hope you're walking away with some ideas on how to flatten your JSON, treat your agents nicely, and maybe, just maybe, simplify that architecture.
And remember, boring architecture is what makes the exciting AI possible. Don't overlook the plumbing.
Couldn't said it better myself. This has been The Vocal Technologist. See you next Thursday.
Spoken Tech for your ears.